Okay, welcome to this video about solving quadratic equations by factoring or quadratic formula. There are a number of ways to solve quadratic equations, but factoring and quadratic formula are the most important, most popular methods. There's a lot to talk about here, so it's actually going to be split into two parts. First of all, what's a quadratic equation? Well, a quadratic equation is an equation, so it contains an equal sign, right? And it also contains a term that has x squared in it. So like 3x squared or negative 4x squared or x squared, right? If it doesn't have an x squared in it, just has an x, then it's not a quadratic equation. If it contains things like x cubed, it's not a quadratic equation. But if it has x squared as its highest exponent, then that's called a quadratic equation. Okay, so we could try, one way to do this is just to guess some numbers, right? We might try some numbers and hope we hit on a solution. Maybe we try negative 4. Let's see if x is negative 4 is the solution. Let's plug it in. Negative 4 squared plus negative 4 minus 2 is 0. That would be 16 minus 4 minus 2. That would be 16 minus 6, which would be 10 equals 0. Well, that was a bad guess. And you could keep trying over and over and over again, but you might try forever and not hit on the solution, particularly if the solution happened not to be an integer. So you could try guessing values, but it's not a very efficient way to find the answer. Maybe we could try graphing. So we'll basically, let's consider this left-hand side almost to be like the equation y equals x squared plus x minus 2, and we can plot the equation by making a t-chart of values, right? We could find an x and we can find a y, which will just be what we get if we plug in x squared plus x minus 2, and then plot some points, because that could at least guide our guessing, right? We could maybe try a 0 first, and that would be 0 squared plus 0 minus 2, and let's see, that's going to be equal to, well, not 0. Right, we're just figuring out what it's equal to. It's actually equal to negative 2. So that means when x is 0, y would be negative 2. Okay, let's try another number here. How about 1? So 1 squared plus 1 minus 2 would be 1 plus 1 is 2 minus 2. That one would be 0. So when x is 1, y is 0. Okay, so that's another point. Let's do 2. 2 squared plus 2 minus 2 would be 4 plus 2 is 6 minus 2. 6 minus 2 would be 4. So when x is 2, then y is 4. I'm plotting points, kind of like we did in Algebra 1, 2. So, I'm seeing a trend here. It looks like this is going up. Maybe I should do some negative values for x and see what happens on that side. What's negative 1? Well, if I have negative 1 squared plus negative 1 minus 2, that's going to be 1 minus 1, that's 0, minus 2. So that's actually going to be negative 2. So at negative 1, this is negative 2. Kind of curious. Let's see what negative 2 is. Negative 2 squared plus negative 2 minus 2. So that's going to be 4 minus 2 minus 2. Well, actually, 4 minus 2 is 2, and 2 minus 2 is 0. So at negative 2, this is 0. And if I did a negative 3, that's going to be negative 3 squared plus negative 3 minus 2. That's going to be 9 minus 3 minus 2. 9 minus 5 is 4. So at x is negative 3, y is 4. And it looks like what's happening is this bottomed out somewhere down there, and then it's now going up in this direction. Okay, so actually from this graph, I could figure out that the solutions for where is this equal to 0 by looking at where the y value is 0. And it's 0 here, right, and here. And so the two x values are, x is 1 and x is negative 2. Those are the two solutions, right? Let's just check one algebraically. If I put, say, well, I did that before, right? If I put 1 in, I get 0 out. If I put negative 2 in, I get 0 out. Anything else I put in, I don't get 0 out. And the graph gives me some level of confidence that I've got the two solutions. All right, but hopefully you'll agree that both guess and check and graphing are some pretty laborious ways to do this, right? It's very inefficient to find solutions that way. We need better ways. Okay, the two ways we're going to talk about in part 1 and part 2 of this video are factoring and quadratic formula. Okay, let's look at that same thing. We know the solution is 1 and negative 2, but how can we find it some other way? All right, well, there's a whole module on factoring trinomials, right? We have a procedure for factoring a trinomial like x squared plus x minus 2, and that involves writing x's here, and then coming up with some way to find the two numbers that go in there. We had a way with a table, right? We made a factor and we said that the two numbers have to multiply to the two outside numbers multiplied, 1 times -2, and they have to add to the middle number, which is 3, or 1 in this case. And so I look at all the different ways of making integers that multiply to -2, like 1 times -2, or -1 times 2, and then I add 1 plus -2 is -1, and -1 plus 2 is 1. And since I want this to be a 1, the two numbers that go in there are -1 and +2, right? So now I've got this x minus 1, x plus 2. So this is the factored version of the trinomial. I've still got the same equation, this left side equals 0, right? But I've just written the left side in a different form. Now, in this form, it's easy to figure out what two values of x will make this equal to 0, because any value of x that makes this 0, for example 1, x equals 1 would make that 0. So let's try that over here. If you take x minus 1, x plus 2, and you plug in 1, you get 1 minus 1, 1 plus 2. But that makes this 0 times 3, and so the entire left side is 0 because that factor is 0. And so x equals 1 is one of the solutions, right? And I have a second factor here, right? And so there's an x value that will make that 0, and that would be -2. Let's check that, right? If I plug -2 into the entire equation, I'll have -2 minus 1 for the left factor, -2 plus 2 for the right factor, and so that'll give me -3 times 0, but the whole left side is 0 because this time this factor is 0. So there's two solutions, x is 1 and x is -2. Okay, so factoring is a fantastic way, very efficient way to find the values. Okay, but that's not the only way. There's another way called the quadratic formula. Okay, it'll give me the same values here, 1, -2. These are the same ones that I got when I graphed the equation. Okay, how do I solve this same problem using the quadratic formula? So here's the quadratic formula, and at some point you should memorize this. X -b plus or minus the square root of b squared minus 4ac over 2a. Okay, so what you can do is you can look at the coefficients here, this 1, and this -2, as the values for a, 1, b, 1, and c is -2. So you just look at the coefficients of the terms. The a is the term for x squared, the b is the one for the x term, and the c is the one for the number term. Okay, and then you would plug those three values for a, b, and c into the quadratic formula. So let me write the quadratic formula out again, this time inserting the numbers, negative, and then b is a 1, plus or minus the square root of the b number squared minus 4 times the a number times the c number. And I'm including the -2 because that's part of the c, all over 2 times a. I just plugged in values for a, b, and c. Now the rest of this is simplifying. So I've got 1 squared is 1. I've got a -4, a 1, and a -2. So a negative times a negative is a positive, and that's an 8 in there. And then a 2 there. I've got -1 plus or minus the square root of 9. But the square root of 9 is 3. So that's -1 plus or minus 3 over 2. And that means there's two numbers here. There's -1 plus 3 over 2, and there's -1 minus 3 over 2. Well, -1 plus 3 is positive 2 over 2. That evaluates to 1. So x is 1 is one of the answers. And then -1 minus 3 is -4 divided by 2 is -2. And so that's the other answer. And that, in fact, is the exact same numbers those are the same numbers that I got here, 1 and -2, and those are the same numbers that came from when we graphed it. Okay? But two different ways. Now, I would submit to you that the factoring way is actually a little less work than the quadratic formula way. But there are times when we want to use the quadratic formula. So let's do this problem together, and you can try this on your own. Pause the video, try to do this with factoring on the left, and then try to solve it with quadratic formula. Okay, here's the solution for factoring. Let me copy the equation again. And I want to factor this, right? So this trinomial means I'm going to copy the 8 first, and then I'm going to end up dividing out common factors. I'm going to be multiplying and adding. The two numbers that I'm looking for here in the factors are going to multiply to 8 times negative 3, so times negative 24, and then they're going to add to 10. If you forgot this procedure, go back and watch the trinomial factoring topic video. Okay, how many ways can I get negative 24 there? Well, it'd be 1 times negative 24, negative 1 times 24, 2 times negative 12, negative 2 times 12. We could have 3 times negative 8, negative 3 times 8. We could have 4 times negative 6, negative 4 times 6. There's a lot of ways to get that. But I want the one that's going to add up to positive 10, and so that's going to be this one right here. Negative 2 times positive 12. So that's what I put in for my numbers, negative 2 and positive 12. But because I had to copy the 8 in both places there, I'm going to have to divide out common factors. So I divide a 2 out on this side, and I divide a 4 out on this side. And I end up with 4x minus 1, and then I end up with 2x plus 3. And that's still equal to 0, right? So at this point, I do have everything factored. Now, what I can do is say, whatever makes this factor 0, which let's figure out what that is, 4x minus 1 equals 0. That's going to be one of the values. 4x minus 1 equals 0. So let's now solve that little equation. If I add 1 to both sides, I get 4x equals 1, and if I divide both sides by 4, I get x equals 1/4. So 1/4 is one of the numbers, right? The other value will come from setting the other factor equal to 0, right? So this procedure works even when the numbers are not integers, where they're fractions. In this case, both of the answers for x, both of the solutions are fractions. X could be negative 1/4 or positive 1/4, or x could be negative 3/2. Okay, so that's how we would solve with factoring. Okay, let's take a look at quadratic formula. We'll do separately. We'll do this with the quadratic formula. So here is the numbers plugged in for quadratic formula, my a, my b, and my c. So I'd have negative b plus or minus the square root of b squared. That's going to be 10 squared minus 4 times a times c, which is negative 3, all over 2 times a. Okay? So x is negative 10 plus or minus the square root of 10 squared is 100. And then I'm going to have to do some let's see, we got 8 times 4 is 32. And then I have to multiply that by 3. Let's see, that's going to be 96, and it's a negative times a negative, so it's positive 96. Numbers are getting kind of big here. And then 2 times 8 is 16, right? 16. So now let's keep simplifying. Plus or minus the square root of 196 over 16. And then what is the square root of 196? I think that's 13. Now if you have a calculator, you can find that quickly. Let me just check it. 13 times 13. No, that's not going to be right. So what is the square root of 96? Is it 14? 14 times 14. Let's check and see. 4 times 4 is 16. See, one thing that's bad about the quadratic formula is you have to do square roots. And not necessarily obvious what to do here. 1 times 4, let's see. Sure enough, 196, the square root of 196 is 14. So now I could substitute here 14. And that means I've got two answers here. Negative 10 plus 14 over 16 and negative 10 minus 14 over 16. So doing some fraction arithmetic here, I could get, let's see, that's going to be positive 4 over 16, which simplifies to 1/4, which is one of my answers. And I can get negative 24 over 16, which we can simplify that by let's say that's 4 times 6 and 4 times 4, and that's actually the same as negative 3/2, and that's the other answer. Okay, so which one was nicer? I don't know. I think that the factoring is a little nicer because the numbers are smaller. But anyway, that's the way we would solve this quadratic equation using either factoring or quadratic formula. Okay, let's take a look at one more example here. And how much time do we have? Not much left. We may have to save this one. Let's see, how much further do we go? This is the last example. We'll see if we can get through it. By factoring, what do we got? We've got x, Going to multiply and add. Multiply to 2, add to 4. Let's see. We got, let's do